We call it the modified distribution method. In short, we call it MODI. And I also demonstrated this. So let's see how we'll do this in our workings. Okay. So working for the shadow prices, if you're not careful with the stepping stone, it's actually the easiest. It's the easiest. It doesn't involve a lot of workings. But if you're not careful on how, like you saw me skipping on some stones that I was using only that which is actually having some units filled in the cell, if you end up using a cell that is empty in the computation of your shadow prices, then you might be getting some misleading result. Like you could be taking the figure of 66,400 not to be optimal, when in fact, in our case, it has evolved to be optimal. You might be making a long conclusion. So we want to look at how else can we find our shadow prices. And the modified distribution method works on the basis of class. Number one, you work on the indexes. Some books, they call these indices. And you're working using what we call equations formed on the basis of the filled cells. Take note, you're computing shadow prices for the unfilled cells, but you first of all get the indexes guided by the equations which are formed using the filled cells. I don't know whether that one is clear. You use the filled cells to come up with the indexes or indices, which will help you now to come up with the shadow prices for the empty cells. So how do we do this? I'm going to baptize my columns. I'm going to baptize my laws. For a law, I'll be using letter L capital. For a column, I'll be using letter K, but you can also use C. I avoided using C because my customers or the destinations were already C1, C2, C3. So I borrowed K, so close to the way you'd pronounce the column, although this is not the first letter of a column. So law-wise, I've defined my laws as law 1, law 2, law 3. Column-wise, I've defined my columns as K1, K2, K3. But law 1, yeah, the L1 indicated on it is not the name of the law. It is the name of the index. The index for law 1, I've called it L1. R2, the index for law 2. R3, it is the index for law 3. K1, index for column 1. K2, index for column 2. And K3, the index for column number 3. Those figures are not given. We have worked for those particular figures. How did I do this? We are going to use the filled cells only, and the unit cost for those filled cells are the ones to help us form the equations. So the first equation that are formed is this equation. I've used this cell here, it is filled in. Let me mark all the filled cells. That one is filled. Marking where I have some units. And that one, there were 5 of them. So my solution that I obtained of 66,400 is the guiding table. Okay, after the allocation, those cells where we have allocated some units are the ones that I'm using. So to form my equations, how have I done this? I've used the cells which are actually filled in and I formed my equations based on the indexes or the indices, the L1, K1 like that. So for this cell here, it has something, I'll use it, W1, C1, and I'm going to form an equation summing over the indexes alongside that cell, L1, K1, across that particular cell. So L1 plus K1 equals to the unit price for the field cell, in this case 100. I've used this cell, it has something. So L1, the index for that law, plus the index for that column gives me the unit price for that particular field cell. And the field cell is indicated by the units whichever we have assigned there. Which other cell has something? Cell W2, W2C1. So I'll use the indexes in that particular cell, and I'll have L2 plus the corresponding column, the index is K1, equals to the unit price of what we have here as what? 140. Another equation that I can form, we are only forming 5 equations because we only have 5 field cells. From W to C2, we can form an equation R2, the index for that law, plus the index for that column K2 equals to 80 as the unit price in that particular cell. Then we also have this equation here to be formed. Let's use this cell, R2 plus K3. Alongside this column, we have an index of K3. We equate this one to the value as the unit cost in that cell, 140. And lastly, we have this cell whose figure is an amount of 172 is already filled. We can form an equation, R3, the index for row 3, plus K3, the index for column 3, giving us an amount of what? 140. 140. So once you have formed those equations, which I'm hoping maybe you're writing down somewhere, you come and you evaluate these figures we are calling L1, L2, L3 like that, up to the point you have exhausted all the variables. In other words, you have moved from L1 all the way to L3, and then K1 all the way to K3. And I've used the field cells to actually form my equations. That is the first thing we do under the modified distribution method, which you compute the indices based on this. Traditionally, L1 is assumed to be 0. Traditionally, L1 is taken to be 0. And once we have assigned 0 to L1, then we compute all these other indices. So if we put a 0 here, for example, where we have L1, our K1 will be equivalent to 100 because L1 plus K1 was 100. Then the moment we find K1, we find R2, which is if K1 is 100, then R2 will be equivalent to 40 because we'll take the K1 minus from this other side, yeah, the balance would actually be 40. That is R2. When R2 is equals to 40 plus K2 not known is 80, then K2 must actually be 40. Then what else? If R2 here is 40 plus K3 equivalent to 140, then for sure K3, solving the equation, must actually be 100, the figure that I've indicated there. If R3 is not known, but we know what is K3, which is 100. Is it possible to tell what is R3? 140 minus 100 K3, we have 40. And you see now we have been able to find what is R1. Traditionally, we say it is equivalent to 0. R2 found to be 40, R3 40, K1 100, K2 40, K3 is equivalent to 100. Once we have found all those particular indices alongside the columns as well as the laws, it is where we now come and we compute our shadow prices for these empty, cells. And how do we do this? We use the same concept of having the equations here. If we are to have R1 plus R1 plus now the K2 is equivalent to 40, which is, or rather K2 equals to 40, which is giving us a value of 80 here. If you are to subtract 80 minus 40, then it should give us a shadow price of what? A shadow price of 40. So that is the procedure we first of all deal with when it comes to the computation of the indices when we want to find the shadow prices using the MODI or the modified distribution method. Now, after we have computed those the indices, let me show you how you come and you determine your shadow prices. So we are going to utilize the column and the law for the shadow price. I'm looking for some space to write here. So the shadow price will be given by what? Our shadow price will be computed as follows. Take the cell which is empty. Take the cell which is empty. Half the figure being positive, you take the unit cost. For a cell that is empty, take the unit cost. I repeat, for any cell that is empty, take its unit cost, and that unit cost must be positive. You've seen that I've indicated here a positive sign. Then you're going to subtract where it is sitting law-wise and column-wise, subtract the law index. Where it is sitting column-wise, you subtract the column index. And that is it on how you compute the shadow prices for each and every cell that is actually going to be empty. Very simple. It's the same procedure as we were forming the equations. Now we are doing it in the reverse manner because we didn't have the cell filled in. Now we are calling it an empty cell. The procedure is, or the rule is, you take the shadow price to be computed as the unit cost. The unit cost is the value upon where the cell is, and you take it in a positive way, and then you actually minus the column index as well as the law index. For example, here we want to compute the shadow price for cell W1C2. How do we do this? We are going to take the value of 80 here. Let's do it inside the table so that it is faster. The value of 80 here, which is positive, we minus the index law-wise, which is 0, and we minus the index column-wise, which is 0, or rather 40. This will give us a figure of positive 40. Let's move to this cell here, W1C2, which is empty, and we compute its index how? 120 is the unit cost. We minus the law index of 0. We minus the column index of 100. This will give us a positive value of 20. Then we move to this particular index, W3C1. The unit cost is 160. We minus the law index, we minus the column index, and this gives us a value of what? 160 minus 40 minus 100. That will give us a positive 20 as our shadow price. Then lastly, here we have the cell W3C2, this cell here. Its shadow price will be given by the unit cost of 120 minus the law index of 40 and the column index of 40 again. 120 minus 40, 40, 80, we'll have a positive 40 here. Which means since all the shadow prices are positive, yeah, the shadow price of positive 40, positive 20, positive 20, and positive 40 here, in the 4 empty cells, then our solution is actually optimal. Our solution is optimal when we find all the shadow prices to be positive. And I repeat how to compute the shadow price using the MODI. Step number 1, create equations using your field cells. Yeah, using the field cells to help you come up with the indexes column-wise as well as row-wise. Once you have found those indexes, the shadow price of an empty cell will be given by shadow price equals to the unit cost of the empty cell minus the law index minus the column index. That is how you determine the shadow price. If the shadow prices for all the cells which were empty turn out to be positive, then it means the solution is optimal and normal allocation will be better than what we have already done. And therefore, in our case, the solution of 66,400 would actually say it is a best solution or it is an optimal solution. So that is how we move using the stepping stone method as well as the MODI. And the point is we want to actually ask ourselves, what if the sensitivity analysis that we were talking of in LP, what if there is an existence of a better solution than what we have found? That is why we are computing the shadow prices based on the empty cells to find out whether there's a possibility of us moving the units from one cell to another. And if all the shadow prices, so a variate and 4 turns to be positive, then the solution is said to be optimal, or rather that is the best allocation we can actually have. So for this example, as far as the northwest corner method, the solution of 66,400 is the best, as we have proved using our 2 methods, the stepping stone as well as the MODI. Although you just stick to one, you don't have to do the 2 like in an exam if asked to do so. And we find that this is the best allocation that we can do for these units, moving from the various sources, W1, W2, W3, to satisfy the customers in the 3 destinations. Again, this was an example where the demand was equating to a supply, and so it was a balanced problem. Before you compute anything, that's the first thing you check. If it is unbalanced, you create a dummy. In our next session, we are going to look at the wrist cell method, and we'll also look at the Vogel approximation method. Now we can move faster now that we have known how to do the stepping stone. That was my main concern, as well as how to compute the shadow prices using the modified distribution method. We stop there for today. But